Assalamualaikum and good day to Dr. Lawali and Dr. Fadilah. Today I would like to present about my PSM, which is the title Vibration Analysis on Belt Fault using frequency-based technique and verification by machine learning. So I would like to introduce myself. My name is Faizwan bin Azhar. My matric number which is B07170912, and which is my course is BMMV, and my supervisor is Technologist Nur Azizi bin Atiman. First, the content of my presentation slide is first, problem, objective and scope. Secondly, the literature review. Thirdly, the methodology and result analysis, and lastly is conclusion and recommendation. First is the problem, the belt fault problem. So the firstly is the moving component belt are normally too liable to unbalanced power produced in machine. Secondly, the response of a framework as a function of recurrence likewise be deciphered by complex function. Lastly, the previous verification has a low outcome. Next, we move on to the objective of the PSM. Firstly, to develop a test for normal belts and fault belts based on vibration attributes. Secondly, to analyze the vibration signal generated by the test carried out using frequency-based and vibration statistical analysis. The third one is to verify the data analyzed using machine learning technique. We move on to the scope. The scope that I'll be using is a software MATLAB. The type of belt which is normal belt like V belt, 2 belt, and 4 belt, and then verification using machine learning, and lastly the frequency-based signal analysis. And then we move on to the literature review for my PSM, which is there is for first is vibration condition monitoring, second belt, third vibration analysis, and fourth machine learning. Vibration-based condition monitoring is refers to use of sensing and analyzing the system characteristic which is in the time domain, frequency domain, or model domain. As for in the vibration condition monitoring, there is 4, which is repeating forces, looseness, resonance, and condition monitoring. So as for the repeating forces, these repeating forces that acts onto the machine can lead to vibration. It will produce at the machine is due to imbalanced rotation, misaligned, worn, or improper driven machine component. As for looseness, it is often because of unnecessary bearing clearance, free mounting jolts, jumbled part consumption, and broken structure. The vibration is normally tolerated, which will become more excessive and unrestrained. The third is resonance. It occurs vibration is usually when component of a part is exposed to an external force. We move on to the belt. There's 2 belt, which is a V belt, the normal belt, which has a V-shaped belt, and then tooth belt. We have a tooth for the belt. Then we move on to vibration analysis. The vibration analysis that we're using is a time domain, frequency domain, which is FFT, RMS, standard deviation, skewness, and kurtosis. Okay, vibration analysis is utilized to decide the working and mechanical state of hardware. Its focal point is it can distinguish creating issues before the imperfection goes to genuine condition and cause breakdown. Time domain, which is time versus acceleration, and as for frequency domain, which is FFT, frequency versus amplitude. The RMS, which is root mean square, esteem is commonly the most helpful on the ground that is legitimately identified with the vitality substance of the variation profile, and in this way the damaging ability of the variation. As for the standard deviation, is measure of the variability of signal about its mean value. For a variation signal with a mean value of 0, the standard deviation is equal to the RMS value of the signal. We move on to the kurtosis, which is a statistical parameter used to characterize a signal. Basically, it gives a proportion of the peakness of a irregular signal. And then lastly, in the literature review is about machine learning, which there is two, SVM and KNN. Which machine learning is usually referred to model performance or performance optimizer. So as for support vector machine, SVM is an administered AI model that utilizes order calculation for two bunch grouping issues. And then as for KNN, which is K nearest neighbor, the algorithm is a directed order calculation. It takes a lot of name focus and utilize into to figure out how to mark different focus. To name another point, it takes a label point closest to the new point, which are its nearest neighbor, and has those neighbors vote. Next, we move on to the methodology. We have four, which is first flowchart, research design, experimental setup, and then data collection method. As for the flowchart, we start and then we go to the literature review for the component. We move on to the selection of the software to use, which is MATLAB, and then we creating the experiment, the setup, and then we run and generate the vibration signal. If the signal is not good, then we go back to the experimental setup, and then if the signal is generated and good, then we go to the data gathered, and then we move on to the vibration signal, then result and discussion, then end. We move on to the experimental setup. There is firstly we set the experiment is focusing on three type of bed condition, which is normal bed, tooth bed, and fault tooth bed. It was conducted by assemble the parts according to the procedure. The setup of the experiment of the testing for the bed that can be seen on the upper left side. The motor of 0.5 horsepower and maximum speed with 600 RPM, which can be controlled by control unit that contains a frequency converter for adjustment of the speed. The shaft that connects the motor and bed pulley is installed by using bearing block to prevent the shaft misalignment. The DAQ and accelerometer being used in this experiment. As you can see, this is the example of a tooth belt that we're using. Next, we move on to the data collection method. Firstly, which is signal measurement. Signal measurement is used through a laptop computer to generate signal. From the setup, the experimental setup, we put an accelerometer that connects to the AQ, which transfer the signal to the laptop together. And then we move on to signal processing, which is signal processing is carried out using MATLAB to generate the fast Fourier transform. And then we move on to signal analysis, which is the signal analysis is conducted using RMS, standard deviation, skewness, and kurtosis after signal processing, and also analysis using the machine learning. The parameter that we use is 5 seconds for the period of time. The speed is 6 type of speed, which is 300 RPM, 600, 900, 1200, 1500, and lastly 1800 RPM. We will move on to the result analysis. The experiment is conducting using 6 type of speed, which is 300, 600, 900, 1200, 1500, and 1800 RPM. The test is carried out 3 times for each speed on each bed. So there is 4 results here. First is time domain, frequency domain, and then we move on to vibration analysis, which is RMS, and so on, and then machine learning. As for time domain, the spectrum, we can see there's 3 types of spectrum for 300 RPM. The waveform will be consistent and sinusoidal often because of the normal belt. Same as the tooth belt, but the spike, the amplitude will be a bit higher at certain point, at certain time. So it can be differentiated between the normal belt and the tooth belt. And then as for the fault belt, we can see that there is a higher amplitude or higher waveform at certain point rather than the tooth belt. The fault tooth belt have an additional extra waveform that shows that the misalignment or missing tooth. Then we move on to a higher speed, the highest speed, which is 1800 RPM. As for the normal bed, there is a gap shown between the time because because the speed is the highest, so the waveform have a gap, and it shows that one cycle, and then we move on to the tooth belt, which is the gap is none there, but it shows a consistent waveform and sinusoidal. And as for the fault tooth belt, it can be differentiated because there is a higher spike occurs in the waveform. And then we move on to the frequency domain. Okay, as for the frequency domain, the difference in shape and severity of fault condition indication of the type of defect. So as for the 3 type of belt, it shows that the normal belt and the tooth belt are almost identical, but as for the fault tooth belt, the spike is more and higher than both of the normal belt and tooth belt for 600 RPM. And we move on to the frequency domain, which is we can see clearly the amplitude spiking at early frequency for normal belt, and then as for the tooth belt, and we can differentiate at the fault tooth belt that the spike of the amplitude is much more higher than both of normal belt and tooth belt for 180 RPM, 1800. And then we move on to vibration analysis, which is for RMS. As for RMS, the graph shows that the normal belt is more higher RMS at the end of the speed, which is 1800, and then followed by tooth belt and fault tooth belt. As for the standard deviation, the graph is identical to the RMS due to the same because of the mean value of 0. So it will be identical with the RMS value. It also shows that the normal bed is the highest at the end. And then we move on to the skewness. This is the graph for the skewness, which is the graph for the normal bed is a bit up and down, which is it dropped significantly at 900 rpm, and then it goes up again at 1200 and it drops again. As for the vibration analysis for the kurtosis, that shows the normal bed is highest value, which is the peak value at this graph is 4.2, which is held by normal bed. And other than that, the tooth bed and the four tooth bed show a significant drop, and then goes up again. Then we move on to the machine learning, which is SVM, support vector machine. This shows the group for the machine learning, the SVM. So as for the yellow, it is for the normal belt. The orange is for the tooth belt, and the blue one is for the fork tooth belt. Here it shows the X marks which is it is incorrect position, and this is why the accuracy is 85.2% rather than 100%. And then for RMS versus standard deviation, the same goes to as RMS versus kurtosis. The incorrect is more at here, due to the incorrect position for almost every point, and it caused the accuracy to drop more and below 50, which is 38.9%. And then we move on to the KNN, K nearest neighbor. For RMS versus kurtosis, the accuracy is 100%, which is the incorrect point is none. The same as the RMS versus standard deviation, the accuracy is 100%. As we can conclude from this table, there's three types of machine learning, which is SVM, KNN, ensemble, subspace KNN. It shows that the SVM got highest accuracy at RMS versus kurtosis with 85.2, but KNN and ensemble both got 100% accuracy for all the tests. This show KNN work better than SVM with 100% accuracy rather than SVM for three results shown. It indicates that the data set for this vibration analysis is not easily separable for SVM. That will change the shape of the decision manifold that can be used. It shows that the features used is for KNN, not SVM, because of the data set. Then as for the conclusion, firstly, the time domain is not suitable to predict the fault rather than frequency domain, which display the difference between fault and good condition. Then we move on to using MATLAB can produce good data analysis and validate the data. So using MATLAB, we can do the time domain and frequency domain. Also, we can validate data using the machine learning inside the app inside the MATLAB. Then the data gathered for regression analysis for BEP is suitable by using KNN, rather than SVM verification due to the dataset. So the dataset using for this test is more verification by KNN rather than SVM. Lastly, using MATLAB can produce good data. And as for the recommendation, firstly, use more type of bed such as round bed and others, and with more type of fault to analyze, such as for like the normal bed also need to have a fault normal bed, so it can differentiate the normal and the fault normal bed. Then the vibration detector or sensor also can be improved by using more advanced type, and also the sensor positioning could be placed with more range, such as 4 sensor at certain distance, which can make the analysis more accurate and more validate. And lastly, also can make a model simulation using mesh analysis to analyze the stress part caused by vibration. That's all for me. Thank you, Dr. Lale, and thank you, Dr. Fadila.